Marinus and I started Parametric about 2 years back. We both come from a detailing and design background, and in solid liquid separation, heavy equipment, and manufacturing. Sorry, I'm trying to keep it short. I'm a mechanical engineer. I think that's me. You want to go on?
And Marinus?
So as Bruce said, Bruce and I met about 10 years ago, and we worked together in the solid liquid separation field, designing mainly thickness and vacuum valve filters, those sort of things. And we learned that Tekla Structures was one of the better tools to use to develop steelwork and design steelwork. So the offer was, for the client was that we would scan the mountainside that we will showcase just now. So we produced a 3D scan, and then we designed a staircase that fit inside the mountainside, which you'll see in a few minutes after we've shown you. Bruce and I are basically the main team that put together the entire thing. The design and everything was done by the two of us. Our client was mainly Cape Nature, and unfortunately the erectors and fabricators couldn't join in on this meeting, but we can speak for them.
Okay, great. So can you give us a little bit of a brief description of the project?
Sure, Bruce, do you like to?
I have enabled screen sharing, so you're able to share screen if you need to.
Can I screen? Okay, 100%. So I think what I'm going to do is I'm just going to quickly share the actual scan before we design on top of it. Just make sure I find the right screen here. As you can see, this is the photograph produced by the scanner, 3D scanner itself. So you can see it's very rural, and I think it took us about 40 minutes by 4x4 to get to the specific site. So this is a nature walk called the Whale Trail, and the guys basically, what is it, 4 day? It's a 4-day trail.
Yeah, it's one of these high, long supported hikes. Sorry, you carry on.
No, you carry on.
It's a long supported hike, and it's staying overnight in hiking trails, but a 12 to 16 kilometer trip between huts. And what they're finding is that the age of the hikers is getting older and older. So Spencer, this is for you. This is your next stopover. And this climb used to be that people would happily scramble down the hill, but I think Cape Nature's got some eye on legal liability. And so you can see in that picture the rotten old chain and stick ladder that was going down the mountain, and they've actually closed that off. They don't want people to use that ladder anymore. And it's quite precarious going down, even with that ladder. Without the ladder, it's quite difficult to get down. So these are hikers with a backpack going down to the sea for a picnic at the sea from the coastal trail up above the coastal cliff above the sea. And they'd go down to this famous place called Stilgat. They'd have a swim and a picnic, and they'd go back onto the hiking trail. So it's quite high exertion to get down there. And Cape Nature was really quite concerned about the liability of someone having an accident. And so someone on the project, someone at Cape Nature, in trying to dress up this trail to increase the marketability of the trail, one of the employees at Cape Nature suggested that they built a much better and safer walkway down to the sea.
So you can see the 3D scanner. The 3D scanner is basically positioned in quite a few places to find a reference from the previous 3D scan. And all of these little dots that you see around here are places or positions where we set up the scanner to scan the mountainside. The scanner is pretty easy to deploy. It weighs about 2-3 kgs, and we can take it anywhere, as you can see. So we managed to scan the entire rock face and rock cliff. As you can see over here, I'm just going to put on the actual 3D scan. So what you saw over there was the photograph, and then over here, what you're seeing is the product of the 3D scan. So you can basically zoom in to any position, any rock face, and pick it up. This is then imported into Tekla, and then on top of this 3D scan, we would design whatever. So we mainly use it in the mining industry to scan existing infrastructure and then do alterations onto the existing structure. But yeah, it was quite unique in what we did. So I'll minimize this and then just show you.
What Marinus What they wanted was they wanted a very, very low profile walkway. It had to follow the contours of the site. And using a conventional, or even using a camera and a tape measure, we would never ever have managed to capture the site in any way that we could go back to our office and design a walkway. And the other problem was that this 4-hour trip, the trip to get to site means they could never bring an 8-ton truck with a hive and a walkway in large pieces. All of the pieces had to be carried into site, basically man carried. So everything had to be kept to around 100 to 120 kilos per largest element, so that we could carry it in and then rig it down the mountainside to install. So everything you see here had to be small and modular and not too dangerous that it would endanger the person who was putting it in.
So this here is the actual, so there you can see the existing old staircase or ladder frame. And this is the new staircase interfaced with the 3D scan to ensure that it all fits. So you can see you'd climb down all the way from on top there down to this last level over here. So as Bruce mentioned, everything is bolted together like a Meccano set. The big problem they had on site was the mist coming off of the sea because it's so close to the ocean that you couldn't just use normal standard steel stair treads. And we've got a wood embedded steel carcass. So there's a steel carcass, if I hide this over here, there's a steel carcass that then embeds the wood so that they, after fires or so on, can replace the wood and still have a steel carcass to walk on to do so.
The other thing is that ideally this should have been a stainless steel job. There just was not money in their budget to pay for stainless steel. So we had to go for a galvanized and painted solution on this job. So it was all about keep designing something that was economically feasible. So it may not, if you look at similar things in Europe to caves, visit sites to caves, they spend a lot more money and their solutions are far more elaborate. We had to produce something economical. We had to work to a very tight budget.
So there you can see the staircase installed inside. As we said, it was quite difficult for the team to get it there, and then to get it from the top of the mountain, if I can zoom out. So you'd stop, the closest you can get is somewhere around where my mouse is now, a little bit further up by car. So if you look closely, you'd be able to see a little foofy slide over there, or what would you call it?
They rigged the cableway in to bring the
so the cableway. So they hung the steel from this cableway, slung it into position, and then carried up. Then started bolting it into place over here.
Are we talking in the kind of detail that you're looking for?
Yeah. For me, yes. Can I ask a question?
Please do.
When you rigged the stairs in, did you bring down the stringers piecemeal and then bolt the treads in, or did they assemble a flight?
They brought it in piecemeal. So we rigged it in and then bolted it all together once it was in position.
Right, yeah. Otherwise, it's just too heavy.
Too heavy, absolutely, yeah.
And it's slightly misleading. The pictures are misleading, but the slope is steep enough that if something started to run away, it would hurt you badly.
Yeah,
So
no, sure.
it made sense to install in situ. And
with the wind there, it's also horrible.
So something that's not obvious here is the distance from anywhere. You had to get to site with every last piece of equipment, and they caught out, Cape Nature caught out someone the year before mixing concrete with seawater, because there's no water for about 15 kilometers around the site. So they actually caught someone mixing concrete with salt water. So we tried to reduce the amount of concrete on the job, and we tried wherever we possibly could to detail the steelwork that would be bolted into the existing rock face using polyester anchors rather than casting concrete plinths.
Right. Do you know how many cubic meters of concrete you ended with?
We could ask the QS. It wasn't a lot. It was more of a nominal issue than it was tiny.
Tiny amounts, yes.
Yeah, sorry, one more question for, I think it was Marinas who explained the scanning.
Yeah.
How much data was involved? Meaning, how big a file did you have after the scan?
The scan of this site over here, it was around 15 to 20 gigabytes of data.
Oh, that's one month.
Yeah, so using some software offered by Trimble, the developers of Tekla, you can downscale that so that it's easier to handle within Tekla itself.
Okay.
But we have some scans that varies between 1 terabyte to 4 terabytes in some cases.
Yeah, that's a, you need a nice hard drive for that on site or what?
Yeah.
So typically, Emmanuel, what we did is we went to site for 2 days to scan. We had obviously never done a job like this before. This is really, it's more novel than people realize. So we went to site and we scanned during the day. Then we went back to the overnight accommodation. We checked that we got a good scan. And we found that the scanner was not actually sympathetic to the environment. Scanners like industrial sites where you can get bolt heads and locating features that they can splice all the scans together. And these rocks and boulders don't have identifiable vertexes and points that you could use for the splice. So we had to go back and rescan quite a lot of the work to make sure that we got a cohesive scan over the whole of the set. But the file is so large that it's not really possible to walk around on site with a 20 gig file and to work on the site. So it's about collecting a huge amount of data, but it has to be reliably put together and hatched and spliced together, and then taking that back to the office and working with it.
Yeah, the manual stitching together of the scans took about a week to get it all done, but only because of the roughness of the area that we were scanning. So typically, if you had a lot of flat faces, you can overlay those flat faces onto each other. But because in this environment over here, there were no real flat faces, it was quite a difficult task to get it all matched or stitched together.
How did you decide on which rocks you could attach to and which ones not?
It's a good question. We didn't really know at the time, so we took a lot of pictures with us, and using the scanner's pictures, we could see which rocks were, looked like they were strong enough.
We've actually, it's a good question because that was our first day's work. We took a roll of barrier tape with us, and we stretched the barrier tape. We pinned and pegged the barrier tape to try and make an access path. And so we spent the day testing alternative routes, which we had the Cape Nature guy was with us. And when we finally came to a route, because they also didn't want to cut vegetation. So in addition to being low profile, it had to be non-intrusive. So we spent the day then using barrier tape. We thought we'd peg it into the rock. The rock was too hard, so we had to do a real Heath Robinson plan. And once we had the route, then, and as part of that route, then was also then the anchor points and the starting and finishing points of each element. And so once we had identified that on site, then we made sure that we captured all of those start and finish points with the scan.
And also to add on to Bruce's theory there is that we added a lot of slotting in our connections to allow the guys on site to move the connection around and then have an adjustable connection to ensure that it fits and connects to a proper rock face.
Yeah, that was going to be my next question. How did you actually make it fit?
Yeah.
We've had a lot of experience with doing modifications on site in the Congo and in Zambia of doing mods to steelwork, and we know that with the best intentions in the world, nothing is ever as it seems. So we've become quite adept at slotting and providing for error in drawing, and providing for error in measuring, and providing for error in manufacture.
Yeah, because ultimately you're never really going to face the live loads that one would expect from a walkway like the bridge in the V&A sort of thing. I mean,
Of course.
what are you limited to 8 people on that trail?
Yeah, but of course there's a couple of lookout points. So you're right. You'll never, quite honestly, the design parameters was more about practicality than actually what the design loading was.
Yeah.
But there are some lookout points where I suppose it's possible that all 8 people get together. But
Yeah,
you'll
but I
see
mean, that's your kind of maximum.
yes, never VNA. That you're right.
Yeah. And I think in a design like this, even if your slotted holes did allow for some movement, it's never going to lead to a failure of the system.
No, of course, yeah. No, I see what your point is. Yes, you're right. So, but Spencer, again, when we slot, we do it with some wisdom, so that you slot one end but not the other end, so that it may float, but it'll never fly. Just to extend the issue about distance, the closest you could bring a generator to the site is probably about 400, 500 meters away. So everything that was put in, they used battery-powered drilling machines. You couldn't bring slugger drills and cutting torches to site. We knew that from the start.
You mentioned something about the anchors that you used. What types of anchors were these?
Stainless thread bar and polyester.
Oh, okay.
2-pack polyester. Fisher type product.
And then you mentioned that you cladded the steel in wood. Why was that? Or
just because of the sea mist until about 10 o'clock in the morning, everything can be a bit slippery. So like you can see in this picture, there's an existing ladderway next to our ladder, the one that Marinus is touching now. And all of that wood is all that Tantalus treated timber, and it's all rotten. So there's this constant sea mist in the area. And we knew that steel would be slippery, and we wanted to avoid galvanized stair treads, just because if you slipped on a galvanized stair tread, it'll hurt you badly. So we made up our design of our stair was a piece of bent up steel, and it had rebates in it to accept 2 hardwood slats. And the concept behind that was they do have occasional fires come through here. It's impossible to firefight in this area. And if there was a fire and if the hardwood slat did burn, then there mustn't be a place where someone will step to their death or fall through a gap. So the carcass had to survive the fire. So we made a bent up carcass, which I don't know if you could get a picture of it. We made a bent up carcass out of 3mm plate, and then we countersunk the wooden stair treads into the carcass. So it's something unusual. We made up our design ourselves. We wanted a wooden nose, and we wanted wooden landings higher than so that there was no slippery wet steel, and it had to also survive a fire.
And is that
Sorry, go ahead, Spencer.
That tread, is that a hardwood timber?
Yes.
And just having that pan underneath, doesn't that collect water, make it swell?
It's got drainage holes in it.
Okay.
There are drainage holes in the detail.
Yeah.
Right.
Bruce, you mentioned earlier that your preferred material would have been stainless steel, but due to budget constraints, you guys had to galvanize. Were you guys able to be within budget for this project?
If I recall, I don't remember the exact. Do you remember the numbers? I think I'm 90% sure it was within budget.
Yeah, we were within budget. We actually came in slightly under budget, but due to some extended work that they've now decided to do on site, I think they've got a new budget to carry on with the work. Yeah.
They're not quite clear ever on what exactly their budget is. It turns out they had a lot more money than they disclosed to us earlier. But as far as the budget for this walkway, the steel was concerned, we came in under mass budget.
Because it's quite an elaborate balustrading system.
Yeah.
And that could have been done using industrial hand railing for a fraction of the price.
Again, the issue was if there's a slip and fall, we don't want the risk of someone going through. So it had to be a system that there was no risk of someone going through the stanchions.
And also architecturally, they wanted it to look look aesthetic,
Yes,
or
yes.
be aesthetically pleasing. Whereas I don't think if we used Mentis grating or Mentis handrailing, they would have loved us too much.
Yeah, aesthetically pleasing like the old wire and ladder and rung ladder.
Yeah, well, that's exactly it. Is they changed the scope completely from what they previously had, and we had to constantly adapt our design to suit their architectural needs.
Look, that ladder was built by P.W. Butler. Eh? I mean, it's from when that bugger used to go hunting there or something. So it's an old rock.
Was there an architect involved, or was it you guys who did all of the?
There was an architect, the client's architect, but he never gave us an actual design. We came up with everything and then sent it through to him for approval, and then he would come back and say, no, do it. And, you know, architects don't always understand the structural ability of anything. And then we would have to make it work and then send it back. So it was a bit of a ping pong match between us and the architect. But eventually he was happy with what we came up with, and we got sign off on it.
What was the duty of the architect, Ben Martinez, if he was not really involved in the design, if you guys did the design?
I think it was more to, what did you say, to give it some form of approval to conform with the aestheticness of this unwalked land. So the client wanted an architect to give some form of indication if he was happy with the design or not. If you go up the road from this hiking, from the Stilgat on the hiking trail, there's 3 or 4 different hiking huts that won architectural awards in the last 3 or 4 years. And I think the whole idea behind getting an architect involved is to make sure that it all ties together, if that makes sense.
Denise has a question. I don't know if you guys saw it in the chat.
Yep. So I think I'll kick off and then Marinus will come in with it. But I think it's that same old thing that steel is available for economics. So you use hot roll section for the stringers, an easy workable section. But it's fire resistant, and then it's also malleable. You can shape the stair treads to suit a concept. You could produce a handrail system to suit an aesthetic concept. The client had been considering using fiberglass, those pultruded fiberglass things. And I think pultruded fiberglass is probably the most ugly, hideous thing that you've ever put upon the landscape. It may serve a purpose in that it's corrosion resistant, but it's not fire resistant, and it's ugly, and it's certainly not amenable to following the landscape like steel let us do. So steel let us follow the landscape and produce something that looks quite, it's strong, it's durable, and it. And I
think to add on to Bruce's opinion there is that with steel you can quite easily CNC cut. So all of these members, every last piece of plate was cut via CNC file. So we exported from Tekla the NC file. It went straight to a cut and supply guy, and then it was pre-cut before it got to the shop to get welded. So I think with steel, by using steel, we were able to NC or CNC cut these files to ensure some extra and additional accuracy.
And the last thing, Denise, is that it's repairable. Steel's repairable. There's no other material that's repairable on site. So we saw.
Also very important. It's also recyclable as well, and it's environmentally friendly.
Yeah,
you're right. Yes.
Denise had one other question on the chat.
Sorry, I'm just trying to find the chat here.
She's saying, what are you most proud of on the project?
It's a combination of using the scanner, because we bought a scanner 2 years ago, and you can see that the industry doesn't really know how to use a scanner effectively in this world. So it's a combination of using the scanner and then blending it into using Tekla to work inside the point cloud to model So superimposing the model on the point cloud and working within the point cloud, it's a difficult thing to do, and most people don't work inside the point cloud.
And I think the complexity of the entire project, I don't think any surveyor would have been able to go out there and lay out a staircase without using this technology. I think it would have been a real struggle to get it to work, mainly because of the complexities, including weather, distance, and just the mere fact that me climbing, and I'm 30 years old, me climbing up this rock face, I was out of breath by the 10th time I went up. So I think the scanner made it easy, but I think it's the blend of technology and experience that made this project very exciting.
Just a question relating to that. Is there a maintenance program for this that you guys specified? And did the owner ask for the models?
The owner doesn't care about the models. The owner's running a hiking trail, Emmanuel. I'm not dismissing your question, but as a technical buyer, the owner is not technically involved. They pretty much leave this to you. And so they didn't specify how we do this. And I think they pretty much, they had a concept which was a walkway. They had no concept how it would be delivered. So they left us to make a proposal, and they went quite happily with us. But so now technically the owner is not technically involved. So as to maintenance, they're not involving us. And my guess is their system is an ad hoc maintenance system. I used to survey underground, and I know the limitations and the benefits of survey, but you could never ever have surveyed this job onto a site and produced something that followed the site. And then when queries came from the installation crew, with the scan, we could address those queries and we could give them alternatives. So you could not do that with a survey. It's impossible. You know, with a survey, you've got the survey marks of what you surveyed and nothing else. You have no visualization once you're offsite. So what the scan does is it brings the site to your office. And I think if we're proud of something, Denise, it's about how we use the scan with software to produce a solution that pretty much satisfied the objectives of what they were trying to do.
I think the fact that it produced a solution is really credit to the system. I go wholeheartedly with you that there is no way you could have built this, designed it and built it using any other technology available before.
Correct.
Well done.
Yes, this is a newish approach. Very cool.
Yes.
Thank you.
Yeah.